What's up guys, my name is Edwin and this is absolutely everything you need to know about setting up advanced RAG chatbots in Dify AI. By the end of this video, you'll know how to set up advanced chat agents for your business beyond just making one at ChatGPT or blindly uploading PDFs to a knowledge base and hope for the best. Now, why should you listen to me to teach you about how to set one up? My name is Edwin and I'm the co-founder of Legacy AI, where I've been serving more than 20 retail and B2C clients in the past 6 months with conversational agents like the one you're seeing in this video, so you're learning from someone who's actually done it before in the real world, not just theory. Now let's dive straight into it.
Let's jump straight into Dify AI. If you didn't know, Dify AI is basically a really low-code platform that allows you to build production-ready AI solutions really quickly. And it has got 112k GitHub stars, which is really good, like it speaks for itself. And the good thing about this is, one, it's open source. So you can actually access the code base and you can actually configure it on your own if you want. You can actually self-host it. So something similar to NAN, if you're familiar with it. You can also self-host Dify in your own organizations if you want to. So it's a really good platform for us to build this kind of using drag and drop interface to build this sophisticated, well-engineered AI solutions. And it's not just cool demos. You can actually build production-ready LLM AI applications using this platform. And the way that you can get started is just get your account. And I've already got an account, but once you're in and start the login, you will find yourself in kind of this workspace canvas. And the thing about Dify is there's something called marketplace. So if you want to build something, so for example, if you want different AI providers, you will need to get it from kind of a marketplace, kind of an app store, if you will. And the way to do that, first of all, before you even click on anything, is you should get your settings and configurations first. So the way you do that is to click on settings and you go to model provider. And from here, this is where you can choose which LLM provider you want. So you will need to install these providers in the Dify market space. So if I want Anthropic, Claude, Amazon, if you want Hugging Face, DeepSeek, Gemini, or Llama, some of the open source as well with Llama, there's Maestro, etc., right? There's Llama API. So you can kind of choose whatever you want. I'm just going to keep it easy and just stick with OpenAI. And the way you set it up is just click on Setup, you enter your OpenAI API key from here, right? You save it. And from here, click on the 3 dots, and you can basically configure the system model settings. And the first one is system reasoning model, which is which model that I'm just going to use to build my applications. I'm just going to choose with GPT 4.1 in this case. And from here, you can also choose your embedding model, which I will talk a little bit about. If you're familiar with RAG, you're probably familiar with this already. If not, I'll go through a deep dive into how you build good RAG applications within Dify. The ranker model, I will explain that as well. So don't worry too much about that if you're not familiar with it. But essentially, we'll be using Gina. So the way that you can go is you can go to gina.ai. And this will be something that we will need to use. So just sign up using an account and access your API key this way. And you'll just need to click on Manage API. And you'll just need to create your own API key and import it in here, right? Super simple. I'll explain what it is. Speech to text. If you're using voice applications, text to speech and speech to text is where you build voice applications, which you can just put your own model in. I just choose with the GPT-4 mini text to speech and transcribe, or you can just use Whisper if you want. But it doesn't really matter because we're not going to be using it today. But it's just there if you know. This is where you configure all your models and settings here. Now, when you're done with that, now you can actually go back to the main page. And if you're brand new to this, don't worry. Studio is where you can actually build different AI applications. You have different choices. You can choose workflow, which are more manual not necessarily manual, but step-by-step, more logical data LLM workflow, similar to NAN. But NAN is more on the kind of business application setting. So if you want to connect to CRM, if you want to connect to Outlook business applications, it's easier to set up in NAN. But workflow is where you actually want to have precise and high-level engineering control over an AI-driven application. So it's really, really focused on LLM and AI. You got Chatflow, which is slightly different to workflow because Chatflow, as you know from the name, is more on the conversational use case. So like chatbots, chat agents, voice bots, voice agents, etc. Chatbot is confusing, I know, but chatbot is basically an easier version of Chatflow. So it's like a more simple applications, which we'll be doing today. Agent, the difference between chatbot and agent is that chatbot can't connect to any tools, so it can't actually do anything useful doesn't take any actions in the real world. It can just talk. Its main application is conversational. Whereas agent actually do something in the real world. It can connect it to tools, do tool calling, it can make decisions over the tool, etc. Right? So today, let's keep it simple. The only thing we're going to build is a chatbot for a gym. So I'm just going to use the Pure Gym Canary Wharf because this is the gym that's close to me. So I'm just going to be using this, building a very simple, membership FAQ chatbot in this website, right? That's the use case to kind of showcase you just to get familiar with the Dify use case. So what I'm going to do is I'm just going to create a blank new chatbot. So I'm just going to create from blank. And you can see there's only workflow in Chatflow. In general, in the real business settings, you probably want to stick with one of these. But for now, because we're kind of starting from scratch, we're going from simple, I actually want to give you like a good fundamental overview of what you can do in terms of RAG pipelines. That's beyond just, let me just upload the PDF into the knowledge base and then I'm done, right? That's what most local tools like NAN or like other local platform, WordPress, whatever, that do, the reason why we're using Diff is because we can do more than that, much more than that. We can get much better results, at least in terms of accuracy and relevance, which we will learn, which are metrics in building RAG pipelines. Like, that's why we use Diff, right? And for now, I'm just going to click on Chatbot, right? With a simple setup. I'm just going to give it a name. I'm just going to call it Gym. Description, I'm just going to save it. I'm just going to click Create. And ta-da, this is your first chatbot workspace. So here, the instructions, if you're familiar with kind of these local tools, this is where you can put your system prompts, the instructions that you give to the chatbot. I already have a prompt, so I'm just going to paste it in here, but I'll just go through it with you, just so you understand, right? So you will have here an instruction, right? You're in an FAQ or system chatbot for Pure Gym London Canary Wharf. Your task is to answer user questions about gym facilities, membership options, schedules, opening hours, etc., right? And then you're just going to follow these steps, read the user's question, right? It's always good to have a role. It's always good to introduce the tasks. And it's always good to have a kind of chain of thought prompting technique, which is just do this step by step. Step 1, read the user's question. Step 2, identify if the question is related to da-da-da. Step 3, if the question is about gym facilities, provide clear information about equipment. For opening hours, da-da-da, right? You can kind of see the flow, kind of like step by step, how the chatbot should think. Now, if you're like, man, how do you create this prompt? Like, don't worry too much. You can click on this, generate prompt if you want. And it's actually pretty good. You can actually just, use a prompt generator and you just describe what you want to build. If I say, I want to build a gym chatbot, right? Obviously be more descriptive if you want. Like, you can also use one of their default options, which is, let's say, a travel planning agency, right? Travel planning assistant, etc. This way you can actually generate the instructions, right? And yeah, so if you're struggling with prompts, try that, and it should help you at least with a foundational layer of how to create and structure these prompts. Now, you should also have, in your prompt, you should also give it examples, right? You should always give examples. What time do you open on weekends? It's only open 24/7, because this is what we call field shot prompting, which is giving the models examples to follow, right? So it's more likely to get the answers correct, one, and also teach the model kind of how they should think about answering such questions, right? So I'm not going to go through all of this. This is just kind of examples, questions that you can just make up or use the prompt generator to help you generate. And from here, you can see there is a variable, user question. Now, variable within Dify actually allows us to introduce prompt So what that means, right, is this very strong, long sentence. All that means is if we set a variable, let's say I'm going to call my variable, you can do it in paragraph, select number, short test. I'm just going to name it user question. So user question, right? And I'm just going to save. Now, if I have this, once I set up this variable, you can see that I have the user question variable here. That means that every time when I chat to the chatbot, the user will have to provide a value for this variable, right? Which obviously is really annoying in this kind of chatbot interface, but it's going to come into handy, especially in workflow and chat flow, because when you have more structured logic in terms of how you structure this AI agents or assistants, you're going to definitely need variables, right? Which is not surprising, which is, if you're familiar with tools like NAN, right, or other local tools, it's kind of, standard nowadays. But this is just how you define it within Diffy. But for now, let's just forget about this and just delete that. And for now, I will also delete that. So I'm just going to say user question rather than having a fixed variables, right? And the way you save in Diffy is you click on publish and you click on publish update. This is how you can save this this versioning that you're working with, if you will. Now you've given a system prompt and instructions on how to set up this chatbot, but you wanted to just kind of have a conversational starter first, right? Because right now it's kind of awkward, right? You have to ask the questions. But the way that you can have the AI to ask the first question is click on manage. You can click on conversational open. So what this does is that it actually allows the AI to say something first. So it will say, hey there, thanks for dropping by to Canary Wharf. How can I help you today? Right? So I'm just going to click on save. And you can click on follow up, which is setting up next question suggestions to give a user better chat experience. It's usually recommended to click that on. Text to speech is converted to voice, which we don't necessarily need at the moment. Citations, this is where it's important. Remember, I'm going to explain to you, like a chatbot, if you have never built one before, for it to be useful, an AI chatbot, you will need something called knowledge base, which I'll explain to you why. But if you add on citations, that means that it will actually give you a precise source of information of where the chatbot gets that information from. It will make more sense once I explain, right? Content moderation, right, by using a moderation API or maintaining sense. So basically, it's kind of guardrail. Yeah, just as the built-in guardrails if you want. So you can just use OpenAI moderation, and you can just kind of, turn those on to prevent people from entering inappropriate content or when they're trying to abuse the bot. This is how you can use the moderations, right? And then you're just gonna save. Oh, you need to, I forgot to type in something. So you can just say, but for now, I'm just gonna turn this off. Right, I'm just gonna click on restart and say, hey there, thanks for dropping by to Canary Wharf Gym. How can I help you today? Right? Perfect. Now, vision is where you can import images. So if I turn this on, you can see that I can actually now attach image to the chatbot, so users can actually do that. See how simple it is to allow this, right? And you also have metadata filtering, which I won't be explaining in this video because it's a little bit more advanced, but I will be explaining knowledge. Why do we need knowledge? Now, before we kind of jump into how you do it, let me explain on a conceptual level everything you need to know about setting up a basic RAG chatbot. Now, the first thing we're going to do is any RAG pipelines, at least in Diffy. I'm going to be using Diffy specific keywords, but it can extend to any applications. It has 4 components. Importing the data, which is very common nowadays with these local tools, which is importing this unstructured data, PDFs, text, Word document, whatever you want to call it, into a knowledge base. That's the first step. It's unstructured because it's text data. It's not a structured data like a Excel, right? So this will be a structured data, right? Like it's in a spreadsheet format. This is structured in a table format. Text documents are unstructured. Now you may ask, hang on, why do we need to import this? Why are we doing this in the first place? Like, why can't we just, for example, if I just plug the entire document into the prompt, right? Then the chatbot will have access to specific context, right? Well, this is why. Every LM, as you're probably familiar, has a very, very special feature called context. If you think about, this document right, as the size of this document. Let's say you have PDF of size, let's say 500,000 characters, right? But most of the times, OpenAI models, not OpenAI models, just any LLMs have a specific limit called context. That means that there's a limit as to how much information, how much characters, how much words you can actually stuff inside the model itself. As an example, if I have Claude, which is 200K context window, so let's say I'm using Claude and it's up to here, this is 200K, right? That means that if I stuff the entire document, which is 500K document, it's not going to fit inside Claude, right? If I have Claude here, right? It's not going to fit in here. So that means that all this information will be lost. Like all this information here will not fit in the model. So that is why you need a way for models to be able to retrieve the information that it needs from this 500K document and somehow fit inside this small context window that LLM models usually have. Now, you might argue, like, hey, GPT has 1 million context window, right? Gemini has 2 million. Is it 1 million? 2 million? I think it's 1 million context window. Gemini is 1 million context window. Why bother? Like, why can't we just stuff it in? Well, you're correct, one. But if like when a model has, let's say, 1 million context window, that doesn't mean you should fit 1 million tokens into that. Like, the reason why is because it's because like long prompts usually get confused by the LLMs. So like if let's say you have a really long document here, right? It's like 1 million characters. Anything in the middle, research has shown that anything in the middle is gonna get lost by the LLM. So that is why it's much better to have precise and relevant information being fed inside this context window, as opposed to just brute force plugging everything into this LLM provider. So that is why you might have heard like people talk about context engineering. That's why, because I'm trying to fit inside this context window as concisely and as efficient as possible to increase the performance of these AI applications, right? That is why we need RAG, right? And yeah, we talk about import data, right? So the way you do that, let's do it step by step within Dify, is you can add knowledge. So I'm just going to publish it just in case I need to publish it. I'm just going to add knowledge base, right? We have some knowledge, but I'm just going to build it from scratch so you guys understand what's happening. So I'm just going to click on create knowledge. Now there's 3 options. You can either import from file, which is you can import any text format. You can sync it from Notion, or you can sync it from website. Now, for this purposes of our build, Canary Wolf, I'm going to actually scrape from the website. So the way that I do that is by using something called file crawl. So the way you do that is click on configure file crawl, and you will need to go to file crawl. I've already have it configured, so I'm just going to show you guys what I meant. File crawl. So file crawl is actually a web scraping tool that you can just use. Like I use it a lot. And the reason why you don't just paste the entire website, by the way, into a knowledge base is because there's so many like noise within a website document, right? So if you didn't know, a website is done using HTML codes. So there's a lot of different things that are just not relevant, such as the images, like how is that useful? There are many links, right? Links that are kind of useless, right? There's a lot of like useless info, like the map. You're not going to be using the map feeding it into the knowledge base, right? Because it supports text-based data only. So you can see like there's a lot of information that's kind of useless on the website and it's really messy. So that's why using something like Firecrawl will allow you to clean up this data within this website much easier. And once you go to Firecrawl, you sign up an account, all you have to do is copy this API key and go back to Dify and actually paste your API key here, right? And then you just escape. And now you just need to all you have to do is copy the website and paste it here and click run, right? I'm just going to limit myself to 1 at the moment because like I want to keep it simple and I don't want it to run on forever. But you can please feel free to go ahead and basically scrape whatever websites you want, right? So it's going to take a little bit of time. So as you can see, we have finished, configuring the Dify workspace. So I'm just going to click on next. That's the import done. That's the import done. Now it's going to say document processing, and you have like chunk settings and all that. Let me explain in details. The next thing is chunking. Chunking means breaking it down, right? All that means is, you can probably tell from the name, is you have one big document, you're trying to piece it into, divide it or chop it, if you want, into multiple blocks. Think of it like a Lego, right? You have a big Lego project, like a, I don't know, whatever, like a building, Lego building. You can actually take it apart by using different Lego blocks. The same way that you can chunk a document into different pieces. Again, the reason why, again, back to the context window, remember what I said, we want to be efficient. We want to only retrieve the most relevant information to feed into the context window of this AI model, this LLM model, so that it will generate the most relevant output back to the user, right? That's the whole idea. So that is why you will need to chunk it into different pieces, because each chunk will have a very, very small size that is precisely relevant to the user's question. That is why we need to use chunking, which is breaking it down. Within Dify, there's two different chunking methods. There's something called general chunking, and there's parent-child chunking. Let me go ahead and explain general chunking first, which is kind of the way that most people are used to doing it. General chunking within Dify is basically you, the user, have to manually define the text chunking rules, which is, what are the size of the chunks? Are there any overlaps? How do we actually chunk them? So what that means is like, if you go back to this analogy, it's like, how big is each of these pieces that we've divided in the document? How many pieces should we divide this document? How big each piece should be? And should there be any overlap, right, between these chunks, right? These are all questions that we need to be asking, we need to set ourselves in this general chunking method, which if you go back to Dify, right, you can see that there's the limiter, there's the maximum chunk length and chunk overlap, right? So let's go through them one by one. So you can see this horrible /n/n. If you're not a developer, you might be like, what is that? So at the limiter, it's the character user separateness, right? If you can just read through the docs, right? But what this really means is basically telling the AI, how should I chunk the document? Like, what's this specific method I should think about chunking it? Because there are different ways that you can divide it, right? If I use /n, what that actually means is I am going to divide the document by sentence, by complete sentence, right? If you use this as an example, you can see that this is a long sentence, it's a run-on sentence. It's like the only time you see a full stop is here, right? So this is classified as one complete sentence. And if I use /n as the limiter, I'm telling Dify that I'm going to be chunking this document by one sentence as one chunk, second sentence as another chunk, right? That's how you explain this. But if you use /n/n, that means that I'm going to be using two sentences, right? So if you go to here, I know it's a long run-on sentence, right? So the first full stop is here. This is the first sentence. The second sentence is run on and on and on to here, the second full stop, right? So /n/n is two sentences as one chunk. Every two sentences, I do one chunk, right? That's kind of the most common way to define how you want to chunk it, right? Which is the delimiter, right? The limiter is how you want to chunk it. For me personally, I like to use /n/n plus. All that means is I can have more than two sentences in my chunking, just because for websites like this, it's usually like very, very like sparse. What it means, if I just show you, if I just use /n/n and I just click on preview chunks. By the way, if you click on preview chunks, you can kind of visualize how your chunks looks like, how it's currently being divided. You can see like, oh, there's like this length, you got the 50% second chunk. This, you know how fragmented this looks? This is because like website data is often very fragmented by definition. So you can see there's 86 character size, like 82 estimated chunks. That's way too many chunks for a simple website. So the way that I like to is group them together more concurrently. So I will just click on /n/n plus. And what this does is it's going to group more things into one chunk. And you can see there's only 11 chunks, which is much better for something simple, something sparse, like a website data. But if your source is like a big, long, well-structured PDF document, a text document, like a text report, then it could be completely different. So the way that you define your chunking really depends on your source of information that you have. And by the way, I usually click on like the delete all URLs and email addresses. So let me quickly explain what this is. Like the text pre-processing rules, which is it will automatically remove the consecutive space, new lines and tab, which is just stop wasting space. You delete all irrelevant URLs or email address, which is very common in websites. So if I just click on preview chunk, like it's basically gone ahead and cleaned it up a little bit better. This is just cleaning, basically. A little to make it a little bit more like less noise, less rubbish, less garbage within this chunk, essentially. Now, we define how we chunk it, but we also need to define what's the size of a chunk, right? What's the size of a chunk? This is how you define it using the maximum chunk length. So each chunk, we have a maximum limit, 1024 characters, right? Obviously, you can change this like if you want to do this like however you want, but usually I'll just keep it at 1024 for now. There's chunk overlap. So you might ask, wait, what is chunk overlap? Why do we need chunk overlap? Like, what do you mean by that, right? So chunk overlap is, as you might know, is the kind of common words or common overlaps, right, between chunk 1 and chunk 2, let's say, right? There's an overlap here, right? Why do we need that? Well, if you think about it, the way that we chunk it normally is by sentences or by 2 sentences. However, the sentence here might be very, very related conceptually, right? Conceptually or semantically, meaning in terms of meaning, the second and first sentence might be describing the same thing. For example, if I say, I like apples as the first sentence, right? The second sentence is, apples are great and they are made of da-da-da-da, right? And they taste like that. Obviously, the second sentence is built on top of the first sentence, but the way that it's being chunked right now by sentence means that chunk 1 is completely independent and unrelated to second chunk. That means we've lost kind of the connection or the relationships between the 2 sentences, right? So that is why we need some sort of chunk overlap so that the AI, when it's retrieving the chunks, it will preserve that connection, that relationship between the first chunk and the second chunk. So that is why we need to use chunk overlap, which is usually around 10 to 20% of your maximum chunk length. That's just based on research that this is the optimal kind of chunk overlap that you should be using. So I'm just going to stick with 50 for now, right? This is general chunking. Now, let me talk a little bit about kind of the more advanced way of doing this. This is kind of the general naive way. This is the more controlled way, which is using parent-child chunking. Click on parent-child chunking, right? So what is parent-child chunking? So parent-child chunking, as you can probably guess from the name, is using the parent chunks, aka the paragraphs, which serve as the larger text units to provide context, while the child chunks, which is the smaller chunks, the sentences, to focus on kind of pinpoint, accuracy, relevance-based retrieval, right? So it's having 2 data structures. It's having one small chunk for accuracy and one big chunk, like a paragraph, for context or for enrichment, right? So let's actually take a look how it works, right? So if you kind of just visualize kind of this diagram, is you have a document. If I use parent-child chunking, that means that I have this child chunking, which is precise retrieval, which is the sentence that we talked about, that will actually, this main use case is for accuracy. And you have this parent paragraphs or multiple paragraphs even to enrich this data, right? And all of that will be plugged into the LLM to generate an answer, essentially, right? And you can probably see how this is a better method, right? Because basically, the first step is you carry chunking with the child chunks, which is more info to match the user's accurate for precision, right? There doesn't have to be one sentence, but you can kind of control it, however. And the second step is the context enrichment, right? With the parent chunks that I just talked about, which is using the larger section to paragraphs to enrich the child chunks context. So how it really works in Dify is you can select your parent chunk, right? Which is the paragraph. Again, within each of the parent chunk, you can decide again how you want to chunk it. So this in here, I'm saying that every like 2 sentences is one parent chunk, right? Because remember, slash n slash n is 2 sentences. I'm just going to put in slash n plus for now, so that it's more feel like one paragraph. And you can select the maximum chunk length, which is how big each paragraph should have. So each paragraph should have 24 characters, right? Or if you want, you can use the entire document as the parent chunk and retrieve directly. So that means that in our example, the parent chunk, rather than using paragraphs, is the entire document will be used to provide context. Now, the advantage is it's going to have a lot of information. The disadvantage is if paragraph 1 is talking about, let's say, apple, paragraph 2 is talking about birds, you can see how paragraph 2 is completely irrelevant to paragraph 1. So the context that you're feeding in using the parent-child chunk method is completely irrelevant. It's completely rubbish, right? So kind of it depends on your document. So it really depends on the use case. That's why you want to switch between the paragraph and the full doc parent-child method, essentially. And you will have the child chunk for retrieval delimiter. This is where we define, like usually we just keep it as 1 sentence slash n, and this is the maximum chunk length for the child chunk for the precise retrieval, right? So if you click on preview the chunk, you can see that it looks slightly different, right? It's a very different like chunking method that we used to. So you can see that there's chunk 1, which is the parent chunk, and you can see C1, C2, C3, right? So these are the child chunks. So this is the sub chunks, right, for precise retrieval, C11, C12, whereas the chunk 1, the big chunk, this is the parent chunk. This is the paragraph that we talked about to enrich the context. Hopefully I'm not rambling on too much and you're kind of understanding this. Like the reason why I've spent so much time is because this is really important to get it right? It's really kind of the bread and butter of everything that we'll be doing. Step 3, index, which is now that you've kind of recap what we've done, right? We import the data, which is using firewall. We break it down into multiple pieces, right? We've done that. And we're now doing organized, because now that you've divided into chunks, we need to, 1, store them somewhere, because where is this information being saved? 1. And 2, how is it being organized? How can you organize this information, right? So these are the information that can be solved by something called indexing. And if you're familiar with RAG at all, you would know that we'll be using a vector database to store these chunks, right? And this is exactly how we're going to do it. So if you scroll down to the Diffy namespace, you will see that there's index method, there's high quality or economical. I'm going to break it down exactly what each one means. So a vector store. So first of all, like a vector is, if you don't know, like you don't need to get mathematical or like geeky about it. Like all that means is something that has a direction in let's say a 3D space, right? So if you literally think of a data point in a 3-dimensional space, right, you can visualize it, let's say a data point living in this space. Each data point can represent like a chunk or a concept. So for example, each chunk, this data point here, it can represent chicken. This here can represent cat. This data point here can represent banana. In the real world, it will have 300 dimensions. This is 3 dimensions because humans can only visualize in 3D, right? But in the real production vector database, it can even have thousands of dimensions, right? So this is a vector database, and the high quality index method really is just, all it is just a vector store, essentially. How it works is you turn chunks, right, which are text, right? Chunks are just these text into vectors. So you turn a bunch of text, right? Text, and you just turn those into vectors. You turn those into vectors like this. And the advantage of using a vector store is you can store them according to semantic meaning. Semantic meaning, what that means is concepts that are related to each other will be grouped together. As an example, if you look at this vector database, if we're talking about fruits, right, apples and bananas are semantically related, right? They are both fruits. That's why they're grouped together in the same similar space that are close to each other. But apple, the computer store, and apple, the fruit, even they share the same name, they're conceptually slightly different things. So they will still be grouped together, but they're not exactly the same because they're slightly different concept. Whereas something like chicken and cat, they're animals which are completely unrelated to computers or fruits, right? So that's why they're being stored somewhere really far away from the bananas and the apples, right? So that is the advantage of using vector databases. You can store them and organize them. Remember, indexing is just organizing information in a semantic meaning, right? In basically how the concepts are related to each other. And that is vector store. Now, we also have something called economical, right? Which is keyword indexing. So economical, if you select, there you go. It's the economical. So economical, as you can see here, is using 10 keywords per chunk for retrieval. So no tokens are consumed at the expense of retrieval items, right? All that really means is that it's using a keyword search method. It's not using, this is using LLM, by the way, because the way that you turn text into vectors is through an embedding model. Remember how I told you to kind of set it up, like using text embedding free small, like in the beginning when you're configuring the settings and the model providers. This is where the embedding model comes in. And it's using the OpenAI embedding model, which turns text to vectors. That consumes tokens, right? Because it's using an LLM, right? So that's basically like cost tokens and it costs money. This technically it doesn't cost tokens, at least, because it's using a keyword search. So it's using what we call an inverted index method, which is basically saying that each chunk will store 10 keywords, right? And you store the information, you organize the information according to the keywords and the frequencies. Let me kind of give you an example of what I mean by inverted index. So the way that we can explain inverted index is, let's explain what forward index really means, right? There's forward and inverted index. Forward index, the usual way of doing it, is you assign the ID to the documents, right? So let's say I have a document or term. If you think about the term or keywords as a document, cat, I will assign the ID 1 to cat, I will assign the ID 2 to dog, I will assign the ID 3 to cat, right? Etc., etc. Whereas for something like the inverted index, it's the other way around. We are mapping the document to ID. We're mapping if cat appears 3 times, right? I'm going to assign the single term document, cat, to multiple IDs, 1, 3, and 6, etc. So how it really works, kind of a more kind of easier way to think about, is we have 3 documents. Each document is 1 sentence. Winter is coming, ours is the theory, the choice is yours, right? 3 documents. The way that it works is you pretty much just divide each word as a term, right? Choice is 1 word, coming is 1 word, theory is 1 word, is 1 word, ours is 1 word, so is 1 word, winter is yours, right? And then you basically have some sort of frequency, like this appears 1 time, this appears 1 time, this appears 1 time, this appears 3 times. You count how many times it appears, and you map it to the documents, right? So this is basically a way of organizing like keywords so that it based on how many times it appears and you can quickly find like which document, which source it comes from. So why am I explaining to you all this, right? It's basically using the keyword indexing. The way that the RAG can retrieve the information back to the user is based on keywords. If I, the user, ask the chatbot about winter, it's going to go ahead and search for the term winter, and based on the frequencies, right, and the document that I signed that we map it to, I can just quickly retrieve the document 1 back to the user into the LLM, and the LLM can then generate a response back to the user, right? So this is how kind of keyword search works, but as you can see, the disadvantage is you have lost all semantic meaning. This inverted keyword indexing method doesn't tell you how concepts are organized together conceptually, right? Kind of like this. It loses all conceptual relationships and meanings. That's a disadvantage. So for now, I'm just going to go with high. You should pretty much always go with high quality. And by the way, if you go with like the parent-child chunk, you can only go with high quality. So that's that. So the final one is the retrieval settings, right? And this is where the RAG pipeline, the final step of the RAG pipeline is search. We've imported the document. We've broken it down into multiple pieces. We've organized them and stored them somewhere. Now we just need to search for it, right? So the way that we do that is under the high quality method, that high quality indexing that we've chosen, there's three different ways to do it. The first way is our standard way, or you're pretty much familiar with, is the vector search. How it works is the user asks a question. So let's say the user, right, they ask some sort of questions, let's say blah, 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 and the text then turns into a vector using the same embedding model, to turn the text into vector and project this into the vector store that we already have. So let's say the user's question is this. It got translated to a vector, let's say this data point here, and it's going to go ahead and see surrounding. Which documents, right, or which chunk, right, that's already in the vector store are closest in distance to this query or the user question vector. Because remember, the closer the vector points are, they're semantically the closer, right? So if I search for the top 3 results, that means that I will retrieve the top 3 closest chunks to my query vector that are most relevant to my questions. And it's going to retrieve those chunks back to the LLM, right? That's what top K means, by the way, because you can see if you go to vector search, you can see that there's a top K, right? That's all that means, is basically retrieving the top 3 closest chunks, right? So I'll go back to 3. And you have a threshold, right? A percentage threshold that you can see, right? A score threshold. It's basically 0 to 100%, or if you will, sometimes it's just 0 to 1. It's basically a score. So what score is that? So usually it's a cosine similarity score. Again, don't worry too much about the fancy term, but you don't need to know about that. Just conceptually, how it works really is basically telling kind of in the vector space how close different concepts are. Because basically the closer the vectors are, like how to define closeness, right? One of them is just by distance, but in a 3D space, it's usually by an angle. So like we have this small angle here. If let's say 2 vectors, right, have a smaller angle, that means they're more related to each other, right? So that is why we use some sort of like similarity score to see how semantically, how close they are. So we're basically saying that if the score is above, let's say 50%, let's say 0.5, only then will I retrieve those chunks, right? Anything that's less than 0.5, that means that semantically they shouldn't be too close to what the user is asking, and therefore I'm going to discard those questions, right? Discard those chunks, right? That is how vector search works. And the second way is by the full text search. So a full text search is basically I'm going to index or not organize all the terms in a document. It's using, again, a more advanced keyword search. It's using a keyword search to go through all the documents, and it's basically running a bunch of algorithms that you don't need to know about, but it's basically using these to judge the relevance to the user's question. In the full text search algorithm, it's able to pick up things like run, words like run, ran, right, that are closely related to each other but slightly different. It's able to pick up these things, and it's going to judge the relevance based on different parameters. Things like word count, how many times do they appear, proximity, how close are the keywords together in this document. This will all influence the full text search results. But usually what we do is using a hybrid search. It's basically, research basically shows that if we use either of those, it's not going to be as powerful as combining both full text search and vector search. That's what we call the hybrid search. This is the hybrid search, which is the recommended way of doing the retrieval search. And the way that you can do that is by weights and by re-rankers. Weights, right, here from here, are basically how should I adjust the kind of strategy of where I should adjust kind of the semantic and keyword ratio. What it means is that, okay, I have this vector search, I have this full text search. How much should I weight those? Like, which one is more important? Should I do a little bit more vector search than the full text search, right? Which one is more important? This is where the weights come in. So if you choose 0.7, so you can set semantic to be 0.7. That means that 70% of the time it should do semantic, and only 30% of the time, like, you should do keyword. Not exactly like that, but just to give you a good intuition to understand what's going on, is that it's going to place more importance on semantic than the keyword, right? But the more optimized way to do it is use something called re-rankers. Now, remember when I asked you to set up Gina AI? This is what the re-ranker models. Now, Gina is basically really good AI frameworks, and they have different models of different embedding models, right? And also different re-ranker models, right? It's really useful for RAG applications. And what are re-rankers? Well, think about it this way. When the user asks the questions, it's doing a vector indexing that we've discussed. It turns into a vector using an embedding model to a vector database, right? Imagine these are all the documents being chunked up, stored in the vector database as vectors. And during a vector search, it's going to retrieve that, right? But the problem with using a top K kind of vector search, pure vector search, is that a vector database is optimized for speed and recall, meaning that it's optimized for speed. You know what that means. Recall is just basically, have I missed anything? I want to make sure that I haven't missed anything, right? That's the advantage of using vector database, is you usually won't miss much by using at least a high top K. But the thing is, just because the vector database retrieval is being careful, it means that only some of the chunks are truly relevant to the user's query. And re-ranker models are optimized models to optimize for relevance. How relevant truly is the user's question to these top chunks that are retrieved from the vector database? That's where this final re-ranker step is really useful. So the reason why it's more accurate is because for the vector database, you never do the user's query and the document simultaneously. That means that every time you run a vector RAG, you index and chunk all the documents in your knowledge base first, and then only then do you embed the user's query. Whereas for the re-ranker model, you're doing both simultaneously. That is why it's able to optimize for actually relevance. So what it does is a model that can go through all the chunks. It's going to re-rank, right, it's in the name, rank the most relevant chunks in ascending order, and only return the truly top 3 or 4 most relevant chunks, right, using a re-rank model. And that is why we always, most of the time, should be using the re-rank model. And the way you do that is you just connect to the Gina re-ranker M0 by configuring the API key within this Dify, right? That's it. That's the entire RAG pipeline. I know it's a lot of information to take in, but to summarize, you import the data, you chunk it down using usually the parent-child chunking to enrich the data, you organize and store it in a vector database, and you just search it using a hybrid search of both keywords, full text search, and vector search. And finally, you use a re-ranker model to truly only retrieve the most relevant chunks. That's the most basic RAG pipelines that you can think of. So yeah, this is all we need to know about RAG. I hope this has been helpful, been really relevant to kind of how do you think about setting up RAG, especially in something like Dify. So I'm just going to go ahead and actually process it. So I'm just going to go ahead and click Save and Process. And now I'll be processing. And now, as you can see, it's finished chunking. So I'm just going to go to Document. And you can see the status is available, right? And now is officially within the knowledge base that we just did. So all I'm going to do is, now that it's saved in the vector store, in the knowledge base within the Dify workspace, I'm just going to go back to the studio and go back to our chatbot. All you have to do is to click on the retrieval, the one that we just did, add it back to the knowledge base, and that's it. And you can just set the retrieval settings by using the re-ranker model that we just talked about. Set it to the re-ranker M0. I usually just go with the top 3 chunks, but you can set 4 chunks as well if you want. Doesn't really make a difference. And you can just click Save. And that's it. You've built your first RAG chatbot within Dify AI. And now let's talk to it. Like, hey there, thanks for dropping on. How can I help you today? So I'm just going to say like, hey, what's how much, right, for membership, right? So that's usually a good question that they will usually, because users usually ask. So as you can see is, remember, you can slice the information from the website saying that off-peak is that much, the joining fee, the core is that much, right? Plus is that much. Then like you've got what do you get exactly in each package, etc. And you can see with the follow-up suggestion, you can actually ask questions like, can I post my memberships? Are there classes included? Is there a student discount, right? So you can just ask questions like that. Is there a student discount? See, you don't have specific information about specific student discounts because it's not in this website at the moment, right? So just say like, when do you guys open? Right, it should be able to answer this information. Right, exactly. So this is kind of the use case, right, where you can have this chatbot on the website to kind of answer questions so that they don't have to ask, the questions that's being asked a million times to the staff members in the gym. I'm pretty sure this is so many people just ask the same questions that can be answered in the chatbot. So the way you do that, you click publish and you go on publish update to save it. Now you may ask, wait, I built this cool chatbot. How do I actually deploy this? All you have to do, there's 4 different options. You can either run app, which is hosted within Dify, which is this website that's being powered by Dify itself, or you can embed it into the website. All you have to do is you click on copy this code into your website backend. So all you have to do is if you, for example, doing it for Pure Gym, you will log into you talk to the web developers who build this website for Pure Gym. You will paste the code that I just copied from here, and you will just paste it within the backend, and it will have a chat widget on your bottom right here, and people can just talk to it that way. This is kind of the standard chatbot settings. And this is exactly how you would deploy it. Really simple. So hopefully this is giving you a good idea of how you want to build this chatbot. I know it's been a long one, but hopefully you get some value out of it. And, if you're a business owner and you've seen value in this, like you think this is something that's useful, please feel free to book a discovery call with me and my team so that we can actually take this a step further and actually build something even more advanced and more valuable for your business. If you want to build some sort of chat agents, AI automations, or just voice agents in general. But yeah, if you enjoy this kind of content, please consider to like and subscribe, and I'll speak to you in the next one.